Hello, welcome to the Math 159 second video for Chapter 2, Section 5, Gould, Theoretical Probabilities. So, in the last video, we discussed the probability rules, and how to compute probability for equally likely events. We will continue now, and we'll be discussing how to combine events, I guess you could say. Alright. Sorry, I'm just writing something really quickly. I lost my little paper. There we go. I was like, where did it go? Okay. So we are now going to discuss combining events. Combining events with and or. Okay, so we'll combine events in two different ways. Okay, so the easy way to do this, I would say, is with a Venn diagram. So I'll do an example and I'll explain how to combine events with an and or an or, and explain what the Venn diagram is along the way. So I guess we'll start with and. So when we say A and B, that means event A and event B. So what do we mean? This means we are interested in the event in which A happens and B happens, or occurs, whatever you want to say. Okay, so what we have here is, hey, something happens in event A, something else happens in event B. We're interested in when they're both occurring at the same time. So let's talk about die. Die 1 is even. That's event A. So if you roll a 2, a 4, or a 6, event A occurs. Event B will be that the sum is greater than or equal to 9. Greater than, equal to 9. So you can roll, for instance, a 1 and an 8. That is equal to 9, so event B happens. So let's say, let's do an example here. Let's say you roll an 8 and a 1. So if you roll an 8 and a 1, event A happens because die 1 is even, and event B occurs because the sum is greater than 9. Let's say, so this is A and B happening. A happens, B happens. Let's say you roll a 1 and an 8 though. Event A does not occur because die 1 is not even. Event B, however, does occur. Okay, so in this case, A and B happened because both of them occurred. In this case, A and B did not occur because both of them did not occur. We're interested in the events in which, I guess I should put in which both A and B occur. Okay, cool. So we are interested in, like, well, how do you do the probability that A and B occurs? Alright, so let's go through this. Okay, so let's start by looking at event A. What are all the things that can make event A happen? Well, event A is when die 1 is even. So if die 1 is even, the lowest even number is a 2. So you can roll a 2 and a 1, or a 2 and a 2, or a 2 and a 3. Or a 2 and a 4, or a 2 and a 5, or a 2 and a 6. Okay, what's the next even number? It's not 3, it's 4. So the next way that you can make event A occur is by rolling a 4 and a 1, and then a 4 and a 2, and then a 4 and a 3. Notice there's a lot of them, right? 4, 4, 4, 5, and then 4, 6. Okay, no, you can't roll a 5, but you can roll a 6. So you can do 6 and 1, 6 and 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. So this is 3 rows, 6 columns. 3 times 6 is 18. There's 18 different ways you can satisfy event A. Okay, now what about event B? Luckily, there's fewer ways to do event B. To do event B, you need the sum to be 9 or greater. So if you roll a 2, is there a way that the next number can give you 9? Well, you'd have to do 2 plus 7. We don't go up to 7 on the die, so you can't start with 2. You can, however, start with a 3. You can roll a 3 and then a 6. That's a sum of 9. What's the next number? Well, you could do a 4 and a 5, or a 4 and a 6. Because remember, it's the sum is greater than or equal to 9. So the 3 and the 6, 3, 6, and 4, 5 are both 9. 4, 6 is 10. That's still greater than 9. Okay, you can also roll a 5 and a 6. That's an 11. You can roll a 5 and a 5. That's a 10. And you can roll a 5 and a 4. That's a 9. All of those are 9 or greater. 1, 2, 3, 4, 5, 6. 6 different ways in B to roll a 9 or greater. Okay, so those are the B events, those are the A events. If you look at it, you can see that there's some overlap. For instance, 4, 5, and 4, 6 occur in B. 4, 5, and 4, 6 also occur in A. The 5, 4, the 5, 5, and the 5, 6 do not occur in A because they start with an odd. Okay, so we're going to single those out. Those are the A. Those are the ones that make A and B true. The oh, I missed. Oops, I'm sorry. I didn't finish all of the B events. Maybe you noticed this, because you can go one more up. You can roll a 6 and a 6. That's 12. You can roll a 6 and a 5. That's 11. A 6 and a 4. That's 10. And then you can roll a 6 and a 3. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different in B. Okay, and then also there's some more overlap. There's all of these 6 rolls. You have these as well as these. So there's some overlap here. There we go. I was like, wait a second. I'm missing something. So those are the events that satisfy A and B occurring. Let's write them down. You can roll a 4, 6. You can roll a 6, 3, a 6, 4, a 6, 5, and finally a 6, 6. So those are the events that occur for A and B. Now there are other events that only occur in A, but do not also occur in B. That's everything after you cross these out. Okay, so that's like a bunch of stuff. So instead of writing parentheses 2, 1, I'm just going to write 21. Hopefully that makes sense, that's what I used to write for 2, 1, because it's just a lot of writing. So you could do a 2, 1, a 2, 2, oops, a 2, 3, a 2, 4, a 2, 5, and a 2, 6, a 4, 1, a 4, 2, a 4, 3, a 4, 4, a 4, 5, and then the 4, 6 ended up in A and B. 6, 1, a 6, 2, and then 6, 3, 6, 4, 6, 5, and 6, 6 ended up in A and B. These are just the events in A. So let's write that down. Okay, we can do the same thing over here for events that only occur in B. That would be rolling a 3, 6. The 4, 5, and the 4, 6. Oh, I forgot the 4, 5, didn't I? Oh, no. 4, 5 is 9. Oh, shoot. Okay, I need to get rid of this 4, 5. I'm supposed to have a 4, 5 here, because it occurs in A and B. Oh, how did I miss that? Okay, so 3, 6. And then you can have a 5, 4, 5, 5, and 5, 6. Okay, so the way this works is I'm going to put a circle around everything that happens in B. And I'm just going to actually draw a circle. Oops. There we go. I'm going to move it. So notice I have a circle around 3, 6, 5, 4, 5, 5, 5, 6, and 4, 5, 4, 6, 6, 3, 6, 4, 6, 5, 6, 6, because all of those are in B. Now I'm going to draw another circle. Actually, I'm just going to copy this one. And I'm going to put it around all the things that occur in A. Now, do you see how 4, 5, 4, 6, 6, 3, 6, 4, 6, 5, and 6, 6 are also in my second A circle, as well as 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on. Okay, so the Venn diagram shows you several things. The stuff over here are the events that only occur in A. This overlapping area are the events that occur in A and B. And by A and B, I mean A and B from the statistical sense. A and B is the stuff that occurs for both. And now these are the events that only occur in B. In other words, they do not also occur in A. So A and B is the overlap between your two events. And we will need this to calculate the probability of A and B. So, well, how many total ways are there, or how many total events are there? So we discussed that there are 18 events in A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of which only occur in A. And then there's 1, 2, 3, 4, 5, 6 of them that occur in A and B. And there are 1, 2, 3, 4 events that only occur in B. So in total, how many events are there? 12 plus 6 plus 4, that's 22. And then how many ways are there to satisfy A and B? Well, the 6 in the middle. So what's the probability of A and B? 6 out of 22. Which, as a decimal, is 0.2727, which you might be more familiar with 27.27%, or we can round up to 27.3%, or round down to 27%, depending upon how accurate you want to be. So what's the chance of getting a die 1 is even, and the sum is greater than or equal to 9? About 27%. You can see how this would be useful for gamblers, because in craps there are different rules that determine how you get paid that depend upon if like certain things are even, or if the sum is greater than a particular number or equal to a particular number. In fact, if you look historically, a lot of probability and statistics was invented by gamblers to figure out more effective strategies of winning. Okay, so that was an example with a Venn diagram for calculating the probability of A and B. I'm going to now do an example with a table. You might remember the contingency and two-way tables. Alright, so bear with me for a moment. I need to open StatCrunch. Okay, so here we have StatCrunch. It's a database of books. You can see you have the title of the book, whether it is a hardcover. 0 means it is not a hardcover. 1 means that it is a hardcover. Is it nonfiction? 0 means it's not nonfiction. 1 means that it is nonfiction. How many pages there are, and what the width of the book is. Okay, so let me go back to OneNote. So there's our data. We are interested in, hey, what is the probability of event A and B occurring? Where event A is the book is a hardcover, and event B is the book is nonfiction. Okay, so I'm going to have to answer this question. I need to make a table that shows me the different configurations of, is it a hardcover, is it not a hardcover, is it nonfiction, is it nonfiction, is it not nonfiction. So let me change this over to StatCrunch. So that's why we learned how to make a table with two categorical variables. We will go stat tables contingency with data. Okay, our row variable will be, because we're interested in being hardcover and nonfiction, so I'll choose one of them as hardcover, one of them as nonfiction. Click compute. And here is my table. I'm going to change this a little so you can see it a little better. Okay, so remember the rows are whether it's a hardcover. So this row here is everything that there are not hardcovers. 22 books are not hardcovers. 3 books are hardcovers. and it goes by columns. This is the one with the 0 right here. This column is the books that are not fiction, or that are not nonfiction. This one means that these are the books that are nonfiction. Now we are interested in the things that are hardcovers and are nonfiction. So I'm going to copy this and paste it back where we were. Ooh, wow, okay, that does not paste very well. Never mind. Let me see if I can copy this better. Copy. Okay, so it says Control A. Okay, whatever. So I was gonna try to copy it over to OneNote, but when I pasted it, it looked super horrible. I guess what we're gonna do is I'm gonna point out we need to know all the different possibilities. So that's this total right here. That's 25. So that's gonna be the denominator of my probability. So we'll go back. There are how many outcomes? Well, there were 25 different books. So I get a 25 of them. And I want to know a book that is a hardcover and is nonfiction. So if we go back to StatCrunch, why is it not doing it? Come on. Switch over. There we go. There we go. So we want it to be a hardcover. We need it from this row. And we need it to be nonfiction, so it needs to be from the column of 1. So there are 3 books that satisfy that criteria. Those are the 3 books that are both a hardcover and are nonfiction. So the answer is 3 out of 25. And what is that as a number? 0.12, which is 12%. Boom. So with this empirical data, there's a 12% chance of selecting a book that is hardcover and nonfiction. Thank you for watching the video.